here we go. Sections 27 and 20 are the last two sections in the packet, and they both deal with exponentials. So section 27 is growth, section 28 is decay, and really, as long as you understand how one of them works, the other one is very simple. So shouldn't be too bad of a day. So the first thing we're going to do is kind of talk about the formula for exponential growth, and then we'll break it down and kind of go from there and talk about it. So first things first, we need a formula. So A stands for the ending amount. And if you can recall back to section 20, which was the interest section, compound interest in that formula, this formula is very simple, or very similar, because compound interest is very much like an exponential formula, because it is essentially. Anyway, so the ending amount equals the beginning amount, and sometimes that's a sub naught, right? With this is the beginning amount. I like to just use the capital letter I for initial amount. You can use whatever you want, but the ending amount equals the initial amount. And then inside here, we're going to deal with the growth factor for now because we're talking about growth. And we're going to raise that to t, where t represents our time period. So remember when we did linear equations that we had two variables, right? Y equals mx plus b, and x and y were always x and y in the formula. Well, when you're writing a model, an exponential model, your ending amount a and your t for time are the two variables that will be in every model. You will have numbers for both the initial value and for the growth factor. So when you're thinking about how do I write these, well, you've got to have the initial amount, you've got to know the growth factor. Once you know those two things, you can write your model. And so that's shows growth. Now, one thing about the growth factor, which we're going to get more in depth here in just a second, if you think about this number, right, whatever I represents, being multiplied by something, and this is growing. Well, if you're going to multiply by something and it's going to grow, it needs to be bigger than 1. And think about just this. Let's just use the number 20. And I'm going to do it 3 times. So if I multiply 20 times 2, I get 40. It obviously grew from 20 to 40, right? So just kind of keep in mind of what number is in the parentheses. If I take 20 times 1, I just get 20. Nothing happened from 20 to 20, right? There, it's constant. There was no growth. There was no decay. And then if I multiply by 0.5 inside the parentheses, I get 10. So there was a decay from 20 to 10. So really, when you think about this, if the number inside the parentheses is greater than 1, we have growth. If the number is less than 1, then we have decay, right, or a decrease. And if the number is equal to 1, then we have nothing. We remain constant because 20 equals 20. Oop, that's an A. So when you're looking at these, if you know you have growth, you know the number inside the parentheses must be bigger than 1. So, okay, let's go more into how do we find this growth factor. Let's go to that next. So the growth factor, we have a couple different ways of finding it. One of them is that we can find it. So one way to find the growth factor is to take 1 plus the percent of increase. And remember that the percent increase, this is the relative change. So if we take 1 plus the relative change, that's finding the growth factor. So that's one thing, that's one way to do it. So if they tell you there was 10% growth, well, 10% growth is the relative change. So 1 plus the 10% would give me my growth factor. That's one way. But they don't always give you the percent change. Sometimes they tell you, like here are the consecutive values. So if you know consecutive values, you can take the new value and divide it by the old value. So 2, but they must be consecutive, like right in a row. If you do that, that will give you the growth factor. Boom. The one other way that sometimes happens is sometimes they just straight up give it to you. So if they tell you that something doubles, well, if it doubles, right, doubles means multiplies by 2. So that would mean that our growth factor would be 2. Or sometimes they might say something triples. Well, triples implies that you're multiplying by 3, so our growth factor would be 3. So really, 1 and 2 are the most common ways. of this, and it depends on how they give you the information. If they give it to you in percent form, you would use the first method. If they just give you values, you generally would use the second method. But you can always find relative change, because remember that relative change from section 23 and 24 is new minus old divided by old. So you can always use that formula that you know to find the relative change to use part 1. So you have options. All right, but you got to have the growth factor to put in the formula so that you have the model. Okay, so that's the basic background information on exponential growth. So now let's get into kind of a multi-step problem here. And we're going to start with a table, and I'm going to cross these out first. Because if you think about it, this is our starting point, right? X is 0. And if we have a starting point, we have no old values. You can't find absolute and relative change without an old value. Because remember, absolute change is new minus old, and relative change is new minus old divided by old. So we're going to do week 1 together just to refresh, because it might have been a while since you remember doing these. But if I'm doing week 1, what would be considered my new value in week 1? Any idea on the new one? If we're talking about week 1, our new value would be 14. And the old is always the most previous, so our old value would be 10. So to find my absolute change, I would take 14 minus 10, and that would give me an absolute change of 4. To find my relative change, right, new minus old divided by old, so I'm just going to put that over 10. I end up with 4 over 10, and my relative change is 0.4. Now when you move on to week 2, that means week 2 becomes new and week 1 becomes old. So as you work through the weeks, you have different values of new and old. So, okay, I'd like you to finish the table, just give you a minute or so, and then you can kind of just make some observations after you fill in the absolute and relative change. This is a good review too. So hopefully you found 5.6 and 0.4 for week 2. And then for week 3, 7.84 and 0.4 for week 3. Any questions on filling out the table? Okay. All right, so now we filled in absolute and relative change. So now let's go to, okay, what do you notice? What do you see? Give me some observations of this table. Relative change is the same, absolutely. And that's really what we're looking for. Are either one of these columns the same? Now, before we get into relative change is the same, and what does that mean, I want to talk about absolute change. Notice that absolute change, this goes back to section 23 and 24. Absolute change is a number, right? 4, 5.6, 7.84, those are actual numbers. If the absolute change had been the same, that would be a constant numerical change. We've seen a constant numerical change before, and that was last week dealing with linear models. So if the absolute change column had been the same, that would have given us slope, because slope is the constant change. However, it is not constant, right? 4, 5.6, 7.84, those are different. So I don't have a linear model because I don't have a slope. I don't have that constant change. But then you look at relative change and you think, hey, relative change is the same. And I know from section 23 and 24 that that's the same as a 40% increase, because relative change is the same thing as percent change, so I can write that as a percent. And because it's positive, I know it's an increase. So it's a rate. We have a constant rate, a percent increase. And because it's a percentage, that tells us that we have an exponential model. So if you have a consistent rate, in this case the relative change is the same, that tells you, okay, you have an exponential model. And we know that the percent increase is 40%, right? That's our percent increase. So the relative change is the percent change, percent increase. We know that from section 24. So now, letter C, let's go ahead and find the growth factor. How do we find the growth factor? Which way are we going to use in this problem? Really, you could use either, honestly. But do you remember how to find the growth factor? There you go, Matt, good. 1 plus the percent change. So I can use 1 plus 40% is the 0.4. So inside my parentheses in my formula, I will have 1.4. Now, if you had used the new divided by old concept that we talked about, let's just use these two values. The new value is the most recent, which would have been the 14. So 14 divided by 10, which would have given me 1.4. So whether you use new divided by old or 1 plus the percent increase, you will get the same thing. Okay, so we have just successfully found our growth factor. Lost my word there for a minute. So now I can write a model. All right, so I'm going to put my model here in blue. Ending amount equals, what's my starting amount in this one? What's the initial amount that we're going to start with for our model? 10. Very good. Just like with linear models, your starting point or your initial amount is when the x value is 0, right? That's your starting point. Same concept. So initial amount was 10. We found our growth factor to be 1.4, and then we're going to raise this to the power of t, where t represents weeks, because t is time period, and this time period is weeks. And again, remember, just like with linear models, if you need to write an equation or a model, you should have two variables, which we do, an a and a t. Okay, and then it says use the model to predict for week 6. What am I going to do with that 6? We're going to plug it in for t. Very good. So a equals 10 times 1.4 raised to the 6th power. And what does that give me? Hopefully you see the connection between the compound interest formulas in your calculator. Very similar using the exponent. We should come up with $75.30. Did you guys get that? Yeah, good, good. Okay, Ashley, you okay? Okay, I'll take silence as consent. Okay, so that's kind of, oh, there you go, good. So that's kind of a really detailed problem with the table and everything else. So let's just do a problem now from a story problem, and I want you guys to try this one. Okay, so frogs increase at a rate of 32% every week. If there are currently 40 frogs around my pond, ... write me a model, and how many will I have after 10 weeks? So just shoot me a yes in the chat box when you have it. And we'll talk about it here in about, I don't know, 2-3 minutes. Okay, so let's start talking through this one. If we want to write a model, we need two things. We need a growth factor, and we need an initial amount. How do I know I need a growth factor, first of all? Any ideas? There you go. Keyword there is increase. Because it tells me that there's an increase, I know it's going up. That's a growth rate or growth factor. Okay, so how do I find my growth factor? Or what is my growth factor? Either one of those answers is fine. Here's my percent increase. So my growth factor will be 1 plus my percent increase, so 1 plus 0.32, which is 1.32. Okay. I also need an initial amount. How much are we starting with in this particular problem? 40, right? There are 40 frogs in my pond. Once I have the initial amount and the growth factor, now I can write a model. So we start with ending amount equals initial amount is 40. Inside the parentheses is 1.32. We raise it to the t power, where t represents weeks, because that is my time period. Okay, so there is our exponential model. Then it says how many frogs will I have after 10 weeks? What do I do with that 10? Plug it in for t. So a equals 40 times 1.32 raised to the 10th power. And did you get an answer? Yeah, but it's huge. Oh. It should just be 642. And I don't think 642 is huge, so let's dissect that. One thing to make sure, you should be taking 1.32 to the 10th power, and your last step is to multiply by 40. That might be an issue depending on how you're punching into your calculator. So make sure that the only thing that's being taken to the 10th power is the stuff inside the parentheses. So depending on your calculator, you might have to type 1.32, raise that to the 10th power, get an answer, then multiply by 40. Did that help? Good, okay. Yeah, sometimes it's just a matter of, how you type it in. And that's one thing. So when you get to the exam here next week, you're going to want to make sure that, on your scrap paper, if you're doing a problem like this and the question just says how much will you have after 10 weeks, if all you do is type the answer into IB Learn and you type it in wrong to your calculation, you get the wrong answer. If you have this formula on your work that you turn in, so I can give you partial credit, I can look at the formula and say, oh man, Matt had the formula written down, he must have typed it into his calculator wrong. I can give you partial credit for that. But if I don't see any work and I only see the wrong answer, I just assume you have no idea what you're doing. Right? So that's one thing that it's really good to just make sure that you're jotting down some basic things on your scrap paper so I can use that as I work through things. So, okay, any questions about exponential growth? Because that's basically section 27 in a nutshell. Okay. All right, so let's go ahead and move on to exponential decay. The difference in formulas is that instead of a growth factor, we have a decay factor. And if you can imagine, the decay factor is found by taking 1 minus the percent change because it's decaying, right? So the number inside that parentheses is going to be less than 1. You can still use the new divided by old. That will also give you the decay factor because if it's going down, when you take new divided by old, it'll give you something less than 1. So it works that way too. So not really anything new. Our numbers are just going to get smaller instead of bigger. So okay, I would like you guys to try to do this one, wrong button, from the beginning. Again, we can't have an absolute and relative change in the first time because we have no old values. So using this, I'd like you to fill in the table, and then notice. Make some observations, what's the decay factor, see if you can write a model, and do an estimation. So I'm going to give you a few minutes to see what you can do with this, and then we'll talk about it. So, okay, try number 4. Okay, are we ready to chat? Can't ever tell because you guys, it's hard to, you can't see anybody. Okay, so you fill out your table. Again, you say absolute change is not the same, so it's definitely not linear, right? Because absolute change is not the same. But relative change is the same, right? So the relative change is the same. And what does that tell us? If these are all the same? Tells us that we have an exponential model. Okay, so to have an exponential model, we need to have something inside the parentheses, and we need to have an initial value. Well, what do these negative signs tell us? Decrease, exactly. So the negative signs tell us that we have a decrease, so we know that we are going to have a decay factor because of the negative. So I'm going to take 1 minus that 0.2. So my decay factor is 0.8. What is my initial amount in this particular problem? 120. Very good. So that makes my model A equals initial amount of 120, decay factor of 0.8 raised to the t power, where again t represents weeks in this particular problem. And if you have a table like this and you're not sure if your model is correct, you can always say, okay, well, let's pretend that t is 3, because I know the answer for 3 is 61.44. So if you take 3 and shove it in for t, and then work it out in your calculator, you should get 61.44. So there, if you know what the y value is supposed to be, or the a value in this case, excuse me, you can always use your calculator and double check it that way. Okay, then the last question here, letter D, says, what is it after 6 weeks? Well, that's time, so we know that t is 6. So a equals 120 times 0.8 raised to the 6th power. Did anybody get an answer for that? Very good. 31.46 is correct. $31.46. Okay. So you can see it's very, very much like exponential growth, except the number inside the parentheses is smaller than 1 because our values are getting smaller. Okay, let's have you guys do one that's not in a table. An SUV depreciates 8% a year. So if you buy a $26,000 SUV, what's the model and how much is it worth after 5 years? So, the key word here is depreciates, because depreciates means a decrease. Okay, so I'm going to give you a minute or two to work through this one, and then we'll talk about it. Okay, if an SUV depreciates 8% a year, what does that make my decay factor? 0.92. Very good. Because we're going to take 1 minus the percent decrease, and 8% as a decimal is 0.08. Okay, what's my initial amount? 26,000. So our model, A equals the initial amount of 26,000 times 0.92 raised to the t, where in this case t is years. So it's whatever time they're talking about in this particular, in the particular problem. Okay, so then they say 5 years, so I know t is 5. So A equals 26,000, 0.92 raised to the 5th power. And how much is that? $17,136.12. Very good. Very, very good. Questions about exponential decay? Okay, I want to do one more problem, and that's it for today. And I want to kind of talk through this one together because we've already done the tables so far. When we work through these and we find the absolute change, right, we get 25 minus 20 is 5. 5 divided by 20, my relative change is 0.25. Then I go to the next one. 30 minus 25 is 5. 5 divided by 25 is 0.2. Next one, 35 minus 30 is 5. 5 divided by 30 rounds to approximately 0.17. So as I look through these, I notice the relative changes are not the same. So this is not exponential. But you notice the absolute changes are all 5. We have, right, so this is now absolute change is the same. We have absolute change. We have a constant change. So what does this tell us? When absolute change is the same, what does that tell us? We have a linear model. Exactly. So we know that this is going to be linear. And we know from last week that to write a linear model, we need two things. We need a slope and we need a y-intercept. So in this case, what is my slope? Based off very good. Our slope is 5. Because 5 is the constant change, and the constant change is the absolute change. What's my y-intercept? 20. Because the y-intercept is the y value when x equals 0. So now that I know my slope and my y-intercept, well, y equals slope times x plus my y-intercept. So here's my linear model, which is part B. And then the very last step, 8 weeks. Okay, well, where does the 8 weeks go? In for x or y? X, exactly. X is the time. So I would say y equals 5 times 8 plus 20. So 40 plus 20 is 60. So in this case, my answer would be 60. So you can use that same table concept for linear or exponential. It's just very important to recognize absolute change tells me I have a linear model and it gives me slope, and relative change tells me I have an exponential model and it gives me the percent increase or decrease depending on the problem. And that's all I really know. All right, so you guys aren't big on asking questions, so just to wrap things up, and I don't have a slide for this time, but you have 2 web work assignments, right? 27 and 28. They're pretty small, I think. Your last quiz and last discussion board. So really only 4 things due this week. And then next week is the exam. So if you have not scheduled your exam yet, please do that today because everybody in an online class is taking an exam next week. So you want to make sure you schedule it as early as possible because you want to get the day and time that you have available. You can take it, actually, if you're ready, you can take the exam this week. It's open. But make sure you get that scheduled and taken care of. Next Wednesday's session, I will be here available from 1 to 2, but it's just question and answers. So as you're preparing for the exam, if you have any questions, you can shoot them to me in an email, and I can prepare them in a PowerPoint, or you can just come in and ask me in the chat box or whatever. Whatever works best for you, we can make that happen. So, but yeah, you have officially finished all of the information. So, and I know it's only 135, but those are quick sections. So if you don't have any other questions on anything, you are free to go. But I can stay around as long as you need to answer any questions you might have. So thanks for participating. Appreciate it.